This is metallic sodium, a soft metal that reacts violently with water. Hard to believe, but it came from a sausage. The first step is to cut the sausage into small pieces. To avoid wasting anything, I simply heat them in water. The sodium salts present are highly soluble, so they dissolve into the liquid, which can then be scooped out with a ladle and transferred to a larger container. At this point, the solution mainly contains sodium tripolyphosphate, disodium diphosphate, sodium erythorbate, sodium nitrite, and sodium chloride. The goal is to convert all of these into sodium chloride, ordinary table salt. To do that, I heat the liquid in another pan until it has completely evaporated. Once the fumes stop, I scrape the residue from the bottom of the pan and transfer it into a graphite crucible containing hydrochloric acid. This step removes the phosphates as phosphoric acid, which is driven off during heating together with the decomposition products of the organic compounds. What remains is a dark residue rich in sodium chloride. To separate it from the carbon, I simply add water. Before filtering, however, I make a simple piece of glassware using two beakers connected by a glass tube. This allows me to do something rather interesting. I pour the extracted solution into the apparatus until both sides are filled. It's important to repeat the salt extraction process several times to obtain enough sodium chloride for the next stage, which is simply electrolysis. I place a small piece of cotton wool inside the connecting tube and insert two graphite electrodes. When an electric current is applied, the sodium chloride is converted into sodium hydroxide on one side, while hypochlorous acid is produced on the other. Without the cotton barrier, the two products would mix and form household bleach. I'll continue using only the beaker containing the sodium hydroxide. I filter it to remove calcium and magnesium impurities before heating it. This causes any unconverted sodium chloride to crystallize, allowing the sodium hydroxide solution to be filtered off. The remaining material is then dried one final time. At last, we've produced caustic soda from a sausage. Now converting it into metallic sodium is surprisingly straightforward. I grind the sodium hydroxide and transfer it into a steel container surrounded by a ceramic fiber blanket, which simply helps retain the heat. I then heat it until it melts, which happens at around 320 degrees Celsius. Next, I insert a graphite electrode and a copper electrode before applying an electric current once again. This time, however, there is no water involved. We're dealing with a molten salt. This process is known as molten salt electrolysis. It allows the sodium ions to be reduced to metallic sodium, which forms droplets that can be collected from the surface. I gathered several of these droplets and stored them in a beaker filled with mineral oil. The electrolysis of sodium hydroxide only works close to its melting point. At higher temperatures, the sodium dissolves back into the molten hydroxide. The process also needs to be paused occasionally to remove the water that forms at the anode and dissolves into the melt. Finally, I melted all the individual sodium droplets together into a single piece. And when placed in water, it reacts vigorously.